Hi guys, it's Mrs. Seitz. Today what you're going to be working on is graphing equations in standard form. So far to this point, you guys have learned how to graph an equation using a table. Another way you've learned is to graph an equation using slope-intercept form. Today what we're going to be doing is we're going to be graphing equations in standard form. So another way to write a linear equation is in standard form. Standard form of a linear equation is whenever you have the x term and the y term on the same side. So a and b are sort of just placeholders for numbers. So I'm going to call those coefficients. And remember, that's just a fancy way of saying the numbers in front of the variables. And the c is also a number, right? But c is a constant because it's a number just hanging out all by itself. So again, this is just a number. For an equation to be in standard form, a and b must be greater than 0. Okay, so an example of an equation that would be in standard form would be something like this. 5x plus 4y is equal to 10, because x and y are on the same side, and then you have just a number like 10 hanging out all by itself. Okay, so some things we need to remember. We're going to be graphing these equations using intercepts. An intercept, like we've used in the past, like a y-intercept, is the point where our graph crosses the y-axis, okay? And words we're going to be using also would be an x-intercept. An x-intercept is the x-coordinate of the point where the graph touches the x-axis. So if I take a look at that line, when I look at the blue line, the place where it's crossing the x-axis is at that point A. We don't know what that stands for yet, but it occurs when y is equal to 0. Likely, if we have on the y-axis where our line crosses the y-axis, it's when the x value is equal to 0, and that's where our line touches the y-axis. So we're going to be graphing 2 points whenever we graph intercepts. So there's 3 steps whenever we are graphing using intercepts. The first step is to find the x-intercept. We are going to substitute in a 0 in for y. The second step is we got to find the y-intercept. So to find the y-intercept, we're going to substitute a 0 in for x. We're going to take those 2 points that we find, and then we are going to simply graph the line. So here's how we're going to do that. All right, so the first thing I'm going to do is I'm going to check to see if this thing is in standard form. Since x and y are on the same side, this is in standard form. So I need 2 things, right? I need the x-intercept and I need the y-intercept. So we just found that an x-intercept can be found by plugging in a 0 in for y. So what I'm going to do is I'm going to rewrite my equation, except this time I don't want any y's to stay in my problem. So I'm going to plug in a 0 anywhere I see a y. So think of it as like canceling out any y in the problem. You only want the x left over. Okay, so I have 2x is equal to negative 4. When I divide both sides by 2, I get an x answer of negative 2. So that means for my x-intercept, I have negative 2 for my x value, and my y value was 0 because we plugged 0 in for y. So if I were to plot that point, which I'm going to right now, remember it has to be a point on the x-axis right here. So that means I start at the origin and I go over to negative 2, but I don't go up or down any units. And I make my first point there at negative 2, 0. All right, I'm going to do the same thing because in the directions it also said I need to find a y-intercept. To find a y-intercept, you have to substitute 0 in for x. So think about as like you want to wipe out any x that's in the problem. So I'm going to take a 0. I'm taking the same equation that I had before, that 2x plus y equals -4, except this time I'm keeping the y in the problem and getting rid of the x. So 2 times 0 is 0, and I get my y-intercept real fast. I get y equals -4. So for the y-intercept, my answer for x is 0, and my answer for y is -4. So to plot that point, I'm going on the y-axis, remember? I'm going down to -4 and making a point. Okay, so I have a point on the x-axis, a point on the y-axis, and the last step, I am going to draw a line. So there's my line, extending it as far as I possibly can, but those are the same 2 points. Now, I could technically solve this thing for y, and I could use slope-intercept form to confirm that I have the right answer, but you still would find that you have the same exact answer. All right, so let's try another one. So again, you need 2 pieces of information. You need the x-intercept, and you need the y-intercept. So to get your x-intercept, remember, you want to keep the x in the problem, so you're going to plug in a 0 in for y. Okay, so -4x, 2 times 0 wipes out the y, so I get -4x equals -4. Divide both sides by -4, and I get x equals +1. So that means I have an x-intercept at 1, 0. So again, the x value was 1, the y value was 0. So I'm going to plot that ordered pair on the x-axis at 1, 0. Okay, now I'm going to do the same thing, except this time I'm plugging a 0 in for the x value because I want the y value left over. So -4 times 0, right? Because you want the y-intercept or the y value left over. So -4 times 0 is 0. So I still have that plus 2y equals -4. I'm going to divide both sides by 2, and I get y equals -2. So again, my x value is 0. My y value is -2. Okay, so that means, here I go, the x-intercept is at -2. So I plotted the 2 ordered pairs. So finally, I'm going to draw a line. And there is my equation that is completely graphed. So again, plotted the 2 ordered pairs, the x-intercept and the y-intercept. That's all you need. Remember, to get an x-intercept, you plug in 0 in for y. To get a y-intercept, you plug in 0 in for x. All right, let's try the last one. Just because there's a fraction, it doesn't mean that you do the problem any differently. So to get your x-intercept, we're going to plug in 0 in for y. Because remember, you want x to stay in the problem. Okay, so I get -1/2 x equals 6. To get my answer, I'm going to divide both sides by -1/2. So when I divide both sides by -1/2, I'm going to get -12 for an answer for x. So that means my x-intercept would be -12, 0. So again, the x value was -12, the y value was 0. To get the y-intercept, and I'm going to do this on the next page, to get the y value, you have to plug in 0 in for x. So I'm going to do negative 1/2. This is to get the y-intercept. So negative 1/2, I'm getting 0 in for x, right? Plus 2y equals 6. And I'm solving for y. So negative 1/2 times 0 is 0. I get 2y equals 6. And when I divide both sides by 2, I get y equals 3. So that means the x value was 0 and the y value was 3. So I'm going to go back to my graph and I'm going to plot the y-intercept and the x-intercept. Okay, so one thing I notice is I'm going to run out of space for my x-intercept. So what I can do, remember, is I can go and change my x-axis. So I'm going to change this and say I'm going to go by 2's. So this is negative 2, negative 4, negative 6, negative 8, negative 10, and that's negative 12. So if I change my x-axis there, remember you have to write down what you're going by if you change your axes. So that's negative 12, 0. And then for my y-axis, I said that value was at 0, 3. So I'm just going to go up 1, 2, 3 and make an ordered pair there. And I'm going to draw a line. Okay, so again, what you need to do anytime you have something that is in standard form, remember standard form is when x and y is on the same side, you need two pieces of information. You need an x-intercept, which is where your graph will cross the x-axis, and you need a y-intercept where your graph will cross the y-axis. It's kind of nice to check yourself on some of these problems because if I go back to things that I've learned in the past, like think about slope-intercept form or even think about the table method, you can use those as ways to help to double check to see if you got the right answer. So for example, I'm going to do this off to the side right now. If I were to check to see if I got question 1 right, I would solve this for y. So if I did 2x plus y equals negative 4, I'd subtract 2x from both sides and I'd get y equals negative 2x minus 4. So that would mean I would have a y-intercept of negative 4, which I do, and I would also mean I would have a slope of negative 2. So that would mean I'd be on my graph, I would have to go down 2 and then to the right 1. Let's see if my graph looks like that. Down 2, right 1 here, yep. If I reverse my slope, up 2, left 1, yep, that's the same thing. I can go here, down 2, right 1, down 2, right 1, yep, that looks like my graph's checking out. So again, you can use those other methods too to confirm if you have the right answer.